Hardware detection. Most hardware is now automatically detected on Ubuntu systems and most modern Linux systems, courtesy of the hardware abstraction layer, also known as HAL. Thus, much of this video is focused on HAL. There are a number of commands and services associated with automatic hardware detection. The ls-hal command lists devices detected through HAL. If there's a problem with a device, the database that's revealed by the ls-hal command can help determine whether Linux actually sees the hardware. If so, then any problem with the hardware is in the interaction with services or applications. If you want a GUI version of the ls-hal command, the UCP curriculum suggests that you use the HAL Device Manager command. But that command front end no longer exists starting with the Hardy Heron release. To get to the functionally equivalent version of HAL Device Manager, type GNOME Device Manager. That's if you're using the Hardy Heron release. It provides quite a view of the variety of devices detected on any Ubuntu Linux system. Another version of detected hardware is revealed with the lshw listing hardware command. Yes, I should run this program as super user, but it still gives me a lot of information. In general, detected devices are primarily either PCI, USB, or PCMCIA devices. Such connected devices can be revealed with the LSPCI, the LSUSB, or the LSPCMCIA commands. The lack of output to the LSPCMCIA command tells me that I don't have any PCMCIA devices on this particular system. Most hardware require modules in order to interact with the kernel. As these are kernel modules, they are often kernel version specific. In other words, if you upgrade a kernel, you'll also need to upgrade the associated kernel module packages. Currently loaded modules can be listed with the lsmod command. A lot of modules there. Note you may not recognize many of these modules, but developers do. If you have a problem with a hardware component that has been detected and suspect that you need to load a module, then there are two basic options. You could insert the module with the insmod command, followed by the name of the module, something like mod.0. You could probe for the module with the mod probe command. If a module had to be loaded with the insmod command, it's a sign that HAL by itself isn't enough, at least for that particular hardware component. And that's true for a few modules, which require a bit of prompting for proper loading. If the module needs to be loaded during the boot process, it can be added to the etc/modules configuration file. Note there are a few modules included in that file. Sometimes modules must be removed before a system is upgraded. Say you're replacing one USB network card with another. In that case, you could apply the rmmod command to the associated module. But most administrators apply the mod probe-r command to the module, as it also removes dependent modules. That's it for hardware detection. SATA Disk management. Disk management, as described in the UCP curriculum, relates to SATA drives. SATA is short for Serial Advanced Technology Attachment. That's the newer standard for PC drives. There are three basic components to SATA disk management: creating partitions, monitoring hard disks, and modifying hard disk parameters. That also applies to CD/DVD drives. One key skill for Linux administrators is the ability to manage disks with partitions and more. To see what you can do with a hard disk, I like the fdisk utility. Yes, Parted is also an excellent tool, but it doesn't quite show the range of partitions and different partition types as fdisk. And fdisk doesn't write changes immediately, unlike Parted. Let's open a disk with the fdisk command. Just in case you make a mistake, it's best if you do it on a disk where you don't need the data. One easy way to do this is on a virtual machine with a newly created hard disk. Back to the subject of the video, SATA disks, which are the newer standard for both laptop and desktop systems. Linux can handle up to 16 partitions on a SATA drive. Examine the types available for a partition. I list the types that can be configured on a partition using the fdisk utility. That's a lot of partition types. If you search through this list, you can set up a partition as a logical volume. In this case, it'd be code 8E, or a RAID array, which would be code FD. Just remember, after a partition is created and written to disk, it has to be formatted to a compatible file system. In other words, if you set up a partition to a Linux file system, it must be formatted as such with a command such as mkfs x3, the third extended file system, the default for Linux, and that should be applied to the partition device file such as dev sdc1. Next, there's hard disk monitoring, which is focused on the smart control command. It's based on smart technology, smart being short for smart monitoring, analysis, reporting technology. The following example lists all smart information for the first SATA hard drive. I'd like to page it to the less command so I can scroll through the output, because there's a lot of output and a lot of good information about the state of your SATA drive. Finally, there's the management of disk parameters available with the hdparm command. This command can help control power consumption and more on hard drives and many CD/DVD drives. There's some old documentation which suggests that hdparm is limited to PATA IDE drives. You can ignore that documentation. To review current settings associated with the hdparm command, try to apply it to a regular drive. Look at that, a lot of information about the drive. Let's examine the current performance of this drive using basic disk and cached reads. That's the sudo hdparm tt command. One of the problems commonly encountered on Ubuntu systems is load cycling on SATA drives. If you encounter this problem, you can disable it with the -B switch 255 applied to the device file of the drive. Ignore the input-output error. Advanced power management is now disabled. And yes, that increases power consumption, but less cycling means a longer drive lifetime. Finally, there's access to the direct memory channel, usually applicable to PATA drives. To see the current settings, say on my CD-DVD drive, I run the hdparm command on that drive without switches. DMA, which stands for Direct Memory Access, is currently enabled, as you can see with the using _DMA directive. You can disable it with the DO switch. You can see how it's now disabled, but I like it enabled. There we go, back to normal. That's it for SATA disk management. USB and other hot devices. While USB devices are the only hardware devices of this type listed in the UCP curriculum, there are other devices functionally similar to USB. USB devices were briefly described in another video, and as such can be listed with the lsusb command. Note how this command at the bottom of the screen lists multiple ports associated with buses, as well as devices connected to certain buses. USB devices are also detected during the boot process or when hot-plugged. As such, they're shown in log files such as verilog, syslog. More information about the device is often listed in the verilog messages file, including information such as device model, drive size, and more. While there is no direct reference to IEEE 1394 devices, known also by their trade names, FireWire and iLink, I believe they're equivalent to USB devices in many ways, especially when used for portable storage. While there's no corresponding FireWire command to the lsusb command, detection messages are also compiled, well, not precisely compiled, but listed in corresponding log files. Also in the same category are smart media cards, sometimes also known as smart digital cards. When I insert a smart media card, messages are sent to a number of log files. As strange as it may sound, the verilog syslog file indicates that the network manager of all things works with the hardware abstraction layer to detect the smart media card. I see the smart digital card device name in verilog messages and verilog kernlog. I see syslog related messages in the debug and daemon logging files. Well, those are the basics on how USB and related hot plug devices are detected and logged. Wireless management. There are 3 types of wireless devices listed in this part of the UCP curriculum: wireless network devices, Bluetooth devices, and infrared devices. Detailed wireless network card commands are the subject for another video. In this video, to confirm that there is an active wireless device, run the iwconfig command. As shown here, the output tells me a lot about the detected and configured device. Let's break it down. The first line specifies the network, in my case 802.11g, and the Extended Service Set Identifier, or ESSID. For my home network, it's Katie Dickens. The next line specifies the mode, which could be a managed node from a central wireless access point, or ad hoc, connected directly to another wireless card. The frequency corresponds to the wireless channel, and the access point hardware address is useful if there is more than one access point with the same ESSID name. Of course, there's a lot more information in there, and to understand how all these options work, see the man page for the iwconfig command. But that's not it with wireless cards. Even with the benefits of the restricted repository, with all its closed source packages, not all wireless devices are detected on Ubuntu Linux. To confirm what's detected, run the lspci command. If you don't see your wireless card in the list, it may not be detected. If it is in the list, you may just need to add the driver module. In that case, there are two major options. First, check the website for the manufacturer of the wireless network card. Some manufacturers, who are open source friendly, add software to their own websites which can help you configure adapters for Linux. If that's the case, at some point Ubuntu normally would incorporate such software into the appropriate restricted repository. Alternatively, if there's a Microsoft driver available for the wireless card, there's a package known as ndiswrapper. It's a project based at SourceForge. The ndiswrapper package, also available from an Ubuntu repository, enables Linux access to a wireless card using Microsoft Windows style .inf and .sys configuration and driver files. Finally, there are Bluetooth devices, short-range wireless devices commonly used for hardware such as keyboards, mice, and headsets. Be aware, Bluetooth devices are configured in various files in the etc/Bluetooth directory. Finally, there are still infrared devices, also known by the IRDA acronym. IRDA stands for the Infrared Data Association. If you have and want to configure an infrared device on Ubuntu Linux, install the IRDA-utils package. Even if you don't, install it for the purpose of this video. Infrared devices are configured in the etc/default/IRDA-utils file. The directives in this file include excellent comments which can help you understand infrared configuration in detail. And infrared devices are controlled by service scripts in the standard etc/init.d directory. There are two major infrared device service scripts, IRDA setup and IRDA utils. Thanks, and on to the next video.